Now, how to perform read and write operations. So first we will understand that how to perform write one operation. So we will launch ideal window. Then there are some basic things that we have to add the model library that you have learned in previous section. So in this you just have to remember the path, that is path is dog, then computer, then frog, cadence, foundry, GPDK, design kit, model, HSpice, then TSP, then TT18. Then we have to perform the, then what we have to plot outputs to be plotted. Now we would like to plot BL, BLB, U, QB. Okay, then we have to perform the DC analysis, design variable. Okay, first we will go for the transient analysis, that is we will for 10 nanosecond left. Okay. Now there is a one new thing that we have not given any DC external supply. So how to test our circuit? First thing is that we have to connect externally. We have to instance DC volt source from analog library. But for testing part, we can do one thing, that we will give some initial values. So there is an option that is called stimuli. So in this part here you can see that there are normal pins. So all these pins are off. So what we can do, we can activate all these things from this place. So let first is ground. So this is first we press enable, then ground. What we require 0 voltage. So this is a DC type, so we can select here DC, and DC voltage is 0 and apply. Same we will do for VDD, enable DC and 1.8, apply. Now for write one operation, okay, another thing is WL. We will require WL, that is also fixed DC and 1.8. Now for write one, what we learned in theories lecture, that let assume initial value of Q is 0 and in QV is 1, and we will precharge the both the bit lines. So first we have to precharge. So for precharge we will select BL as a enable DC. We will precharge it till 1.8, and opposite values for BLB 0. Okay, now everything is clear. So we have precharged the BL and BLB. Now close this window. Now one another thing where we consider that, let assume that initial value. Then how to set the initial value here? So for initial value we will go for simulation, convergence at, and then initial condition. So for initial condition we require 1.8 at QB and 0, type 0, select that and select that wire that where we want to put the initial condition. So this is the Q. So here this is initial value set to Q. Then okay. So Q is set to 0 and Q is set to 1. Now we would like to write 1. So means that our Q is switched to 1 and QB will be switched to opposite value. So we will see whether it is performed or not. So we will say check and save, and we will simulate this. So this is the simulation performed for 10 nanoseconds. So here what we think we have to understand, that the switching time is very less. So we will maximize this by break down this scale. So here what we can see here for this duration. Let's zoom. that what we did, we set the BL at initial level this to 1.8 and BLB to initial level 1.8. Now the initial value of QB was 1.8. Now write one operation. So QB is set to the 0 and Q that was previously 0 now is set to the 1. So we can say that our write one operation is performed because the initial value we set to the 60 SM cell, that is 0. Now we are getting 1. So write one operation is performed. Now to write 0 operation, just we have to put all these values opposite. That what we have to do, we have to set BL to 0 and BLB to 1.8, then save, and same opposite value we have to put for initial condition, that QB is set to 0. Okay, Q is set to 1.8, apply, and another value Q0 is set to QB. So okay, now check and save and we'll perform the simulation again. So here we will get the new graph for right 0. As we can see that initial value of Q was 1, so it is dropped to the 0, and the initial value of QB was 0, so it is dropped to the 1, while VL and VLB remain constant. So here we perform both read and write operation. Now if you want to calculate the rise time, delay time, whatever you require, so as from the definition we all know that rise time is the time taken to rise the pulse from 0 to 90%. So here the 100% value is 1.8. So the 90% value of 1.8 will be around 62 volt. Sorry, 1.62 volt. So we have to calculate the rise time. So around 1.62 will come here. So here we will consider the 1.62 value and then the relative value for 7 picosecond. But if we are facing difficulty, then we can place the marker. So how to place the marker? There is a option marker, that create marker. Now it will depend on which type of marker you want. First one is horizontal marker, then press OK. So here we get the marker, so we can drag and drop that marker. Okay, I think that is overlapped, so we can place another marker, create marker, that is horizontal. Okay, now we will drop, drag. So here we will put this to 1.62. So here you can easily get the crossing values, that is 71.71.00 picosecond. So 71 picosecond is the rise time for write 0 operation. So if you will drag it here to the 50% value, that is 0.9, then you can calculate the delay. So here these are the things. You can also place vertical marker here, that if you want and cross value, then you can use these things. You can also use shortcut for pressing vertical marker. You can directly press V, and for horizontal marker you can press H. So here you will get the markers.